Assalamu alaikum everyone. In this video we'll talk about type 1 partial fractions. Okay, so here type 1 says the denominator g of x contains non-repeating linear factors ax plus b. Okay, the denominator here, the denominator, that is nothing but my g of x, contains non-repeating linear factors. Okay, the denominator will have a linear factor and it is not repeating. It doesn't have a factor, it has factors. Okay, it can have one, it can have multiple. Okay, and suppose it is in the form of ax plus b. The linear factor is like this, ax plus b. So then how can I solve this? यहाँ तक तो पता चल गया कि this is type 1, but type 1 को how am I going to solve? Like this. To every factor of the form ax plus b, if the factor is of the form ax plus b, which is linear factor, in the denominator a partial fraction of the form a by ax plus b must be assumed. Okay, we are assuming that that fraction will have a factor, that factor will have a fraction like this, a constant over the factor. Okay, I have got a factor. So I'll write, suppose this is the factor, linear factor, then I'll write, I'll decompose it in this form. Okay, I'll reduce it in this form, a by ax plus b. A is nothing but a constant that we need to find out. Okay, let's quickly look into an example. I think this is clear. We'll have a, in the denominator, we'll have a non-repeating linear factor that will decompose it in this form, a by ax plus b form. Okay, now let's look into an example. Suppose the example is 3x by x minus 2 into x plus 1. So here if you see, I've got two different factors which are linear. X minus 2 is linear, x plus 1 is also linear. Now, so for every factor, for this factor and as well as this factor, I need to write the partial fractions for both of them. So here see, this is my question. For this factor, I'll have a partial fraction of the form this, a by, the factor is x minus 2. Ax plus b is the factor over a constant. So similarly, x minus 2 is a factor, for that a by x minus 2, a constant over that. Next factor I have x plus 2. So I'll write, x plus 1, I'll write x plus 1. Even this is a linear factor, so I'll reduce it in this form, a by ax plus b. So after a we have b, a constant b, so I'll write b by x plus 1. You can also write a1 and a2. Okay, in some textbooks it will be a1 and a2, some it will be a, b, c, like that. Okay, I think I'm clear. This factor is reduced to these two partial fractions. For this factor, this is the partial fraction. For this factor, this is the partial fraction. Okay, let this be my equation 1. Now next, step 2 was to take the LCM. I'm taking the LCM here. Okay, x minus 2 and x plus 1 both are the LCMs. Now after taking LCM, the numerator is this, the denominator is this, the numerator is what? A into x plus 1 plus b into x minus 2, the cross multiplication. At this point I believe that you people know how to take out LCM, so I'm not doing this in detail. Okay, so now here this is the LCM part. After taking LCM, if you see on the LHS and on the RHS, the denominators are same. Okay, so I'll cancel out the denominators. So that I'm only left with a simple polynomial. I don't have a fraction. Okay, so after reducing, after cancelling this out, I'm left with 3x. 3x is equal to a into x plus 1, a into x plus 1 plus b into x minus 2 plus b into x minus 2. The denominators are gone now. Now let this be my equation 2. Now after getting the equation 2, see here, we have got two constants, right? A and b. Now I need to find the values of a and b. I told you there are two methods. One is to equate the factors, these factors to 0, equating the factors to 0, or else we can find the values of a and b with the help of by comparing the coefficients, right? So we'll go with the method 1, first method, that is equating the factors to 0. So see, I've got one factor that is x minus 2. So I'm equating this factor to 0. Okay, I've got a factor x minus 2. I'm equating this factor to 0. So here if you see, this is minus 2 on the LHS. If it goes on the RHS, it will be plus 2. Okay, so x as it is equal to, this 2 is going to the other side, minus 2 is going to the other side, becomes plus 2. Okay, now the value of x is what? 2. That means what? Wherever I find x in this equation 2, I am going to substitute 2 in place of x. Okay, so equation 2, substituting this value in equation 2, 3x, 3 into x, right? 3 into, what is the value of x? 2. So 3 into 2. Now a into x plus 1, a into what is the x value? 2. So 2 plus 1. Then plus b into x minus 2 plus b into what is x? 2. 2 minus 2. So here if you see, this 2 minus 2 is 0, right? 0 into anything will be what? 0. So this term becomes entirely 0. B term becomes entirely 0. Now 2 plus 1 is what? 3. 3 into a is 3a. Okay? Now here 3 2s are 6. So here, yeah, 3 2s are 6. Now see here, this term is like this, 3 into a, right? 3 is being multiplied with a here. Okay, why I'm stressing this big point? Because students mostly get confused because I have nothing in between here. It's not written like this. It is simply like this. So students get confused mostly in this. So 3 here is multiplying, goes to the other side, divides. So 6 by 3 aata. What students does is 6 minus 3, they write it like this, because 3 is adding here. I don't have a symbol, I consider it as positive. So 3 is adding, so it goes to the other side, it subtracts. They think like this. So that's why I'm stressing here. This is 3 into a. Okay, so 3 is being multiplied with a, goes to the other side, divides. Why I'm sending 3 to the other side? Because I only want the value of a. I only need a. So that's why the remaining terms will go to the other side. Okay, so 3 is going to the other side, it divides. Here it is multiplying, it goes to the other side, it divides. So here 3 1s are 3 2s are 6. So the value of a is nothing but 2. 2 equals to a, or a equal to 1 in the same. Done, we got a. Next, I've got another factor, that is x plus 1. Now I'll equate this factor to 0 now. Okay, so case 2, x plus 1 is equal to 0. X plus 1 is my factor. X plus 1 is my factor, which I am equating to 0. Now this here 1 is being added here, right? It is plus 1, right? So it goes to the other side, becomes minus 1. So x equal to minus 1. The value of x is now what? Minus 1. So wherever I find x in the equation 2, I am going to write minus 1 in place of that. Okay, now equation 2 here is 3x. 3 into what is x? Minus 1. So minus 1 as it is. Now next it is a into x plus 1. A into what is x? Minus 1. So minus 1 plus 1. X plus 1, that is, x is nothing but minus 1. So minus 1 plus 1. Now next is plus b into x minus 2. What is x? Minus 1. Minus 1 minus 2. Now if you see here, this term minus 1 plus 1 is what? 0, right? So 0 into anything becomes 0. So this a terms entirely becomes 0 now. I am left with only b term. Minus 1 minus 2 is nothing but minus 3. So minus 3 into b is nothing but minus 3b. Okay. Here 3 into minus 1 is minus 3. I mean 3 into 1 is 3. Plus into minus is minus. So minus 3. Okay. Now this minus sign and this minus sign gets cancelled. I am left with 3 is equal to 3b. This 3 is being multiplied here. 3 into b, it's like this. 3 is being multiplied, goes to the other side, divides. So 3 by 3. So I can cancel this out like this. 1 3 1s are 3 1s are, obviously. So the value of b is now what? 1. See, I got the value of a, I got the value of b. So the final step here is to substitute the values of a and b into the equation 1 to get the complete answer, right? So 3x by x minus 2 into x plus 1. 3x by x minus 2 into x plus 1 is equal to a by x minus 2. What is a here? We got a value as 2. So 2 by x minus 1 plus as it is. Then what is the b value we got? 1 by x plus 1 as it is. So this is your complete answer. This is being reduced into two different partial fractions. Okay, this is your fraction. These two are your partial fractions separated by addition. So this was an example regarding partial fractions. I hope it is clear for you all. If you have got any questions, you can comment down in the comment section below. I'll try to answer your questions. Okay, so that's it for this video. Thank you.